Good afternoon, everyone. I hope you've had a great day so far, and I'm really happy to be here and talk about state machines to you today. My name is Robert, as you've heard. I'm a digital strategist at one of the conference's sponsors. You can find them somewhere here on the wall. And you might be wondering now why a digital strategist is talking about such a technical topic like state machines. And the reason is, I was a software engineer until maybe a year ago, and my teammates thought that I talked too much, so they decided to move me on to a more consulting role and stick to coding themselves. But before all of that, I was a student, a computer science student here in Switzerland, and there was one course that I attended which was called Mathematical Foundations of Computer Science. And that's when I actually heard about state machines for the first time. So I'm going to give you a brief definition, mathematical definition of what they are. A finite state machine is a mathematical model of computation. And as you can see in the top right corner, it's not something new, it's not something modern. It's been around for more than 60 years. And it is an abstract machine that can be in exactly one of a finite number of states at any given time. And it can change from one state to another, and this change is called a transition. And a finite state machine is defined by a list of its states, its initial state, and the inputs that trigger each transition. And that all sounds really exciting and amazing when you put words on a slide, but you can also draw and visualize that. And then it looks something like this. You have a list of its states. So those are those circles that you can see with those fancy little numbers. You have an initial state on the left with a little arrow, and you have lots and lots of exciting arrows that transition from one state to another. And you might be excited about that, but I wasn't a good student. As we've heard, I failed the exam, so I thought, boring. So I focused on other courses, and one of those was called User Interfaces 1, which was also very, very exciting. We learned, for example, what year the mouse, the click mouse for a computer was invented, and it was all very exciting. But what actually drew my attention was the practical exam. And while we're at that, I was thinking that my professor from that time might probably be sitting here today. He isn't, or at least I haven't seen him. If you are, hi, I'm sorry about that, what you're going to hear now, but you've given me my grade, so here we go. The exercise was that we had to build a user interface for a library software, like a literal physical library where people go to and they lend books. And the amazing thing about it was that it had to be written in Java Swing. Who has had the experience with Java Swing? Who's enjoyed it? Yeah, you? All right. So one person in the room enjoyed it. I think that says it all. And I mean, a book can have different states, It's in stock, it's available, so people can come and take it home. It might be lent already, or it can be damaged or even lost. So my friend and I, we thought come on, that's an easy exercise, a list with different states. And rather than spending 100 or 200 hours on working on that, we went to a bar on a Saturday afternoon, ordered some beers, opened our laptops, and started hacking away. And it all worked pretty well, until suddenly I got that error message from our own software. The Hobbit from JR Talking is lent until lost. I was like, shit, it should say a date, but it's obviously something's not right. And I didn't connect the dots at the time, because my book was obviously in more than one of a finite number of states. It was in two. And rather than connecting dots, we just ordered another round of beers and started hacking more and more until we finally had a working solution that we could hand in. And with the passing grades, we were happy, And you might think now we're young, naive, and maybe a bit arrogant, but we're not the only ones that run into issues like that. There was the infamous FaceTime bug a couple of years back, and I mean FaceTime's from Apple, video chat software. They know how to code, right? But there was the thing that when I was calling my friend, and before he had even picked up, I could add another person to the call, such as myself, and it would immediately establish the audio connection. So I could listen to what he was saying before he had picked up the call. I mean, what the heck? How can that even happen, right? So let's say you're a dev on Apple's team, and you come in on Monday morning, you have your backlog with the stories that you want to tackle that sprint. You think, hey, adding a person to a group chat, that's fairly easy. That's a good exercise for Monday morning. And you start writing tests, maybe, ideal world. You say, so when my function has run, I expect a person to be in the group chat, and I mean, I want to hear the person, so an audio connection should be established. And then you write your code, and you have a click handler. You think, hey, when the button was clicked, I want to add a person to the group chat, and when the person was added, I'll establish the auto connection. Your tests are green, everything builds. You take your phone out, you go to your friend, you start trying calling each other, and it all works perfectly, right? Because you have your mental model, but at that time, you might have missed some cases that just weren't that obvious. And if you draw out that mental model, you get something like this. Your app, like FaceTime, has 3 different states. It's idle, it's calling while you are actually calling someone, and it can be in an active state when the other person has picked up. So you have also an initial state when you start up your app, and that's just idle. It doesn't do anything. Then you click call someone, the state changes to calling, and it can be either accepted or rejected, and when it's accepted, it's now inactive, and the call can be ended, or a person could be added. And if you look at this model, it's quite obvious that whoever implemented the functionality wasn't thinking about something like this, but thought, hey, adding a person is easy and it should always be possible, but it shouldn't. And what I'm trying to tell you here is state machines really help you to make implicit state explicit by having a visualization. And they also help you to ensure that routines only run when you actually want them to be run and not at any given time. And I really think if you take anything home from this talk is that the concept and the mindset is important of state machines and not the implementation. As I said, it's been around for 60 years. We kind of forgot about it in our industry. But for example, in the game development, it's still pretty popular. You have your character and it's either jumping or it's running or it's moving left, moving right. So they are used to this, right? But in, I think, the last 3, 4, 5 years, it's become more popular again in front-end engineering as well. And there's probably the most popular library. It's called XState, but there are many others. But for the example that you're going to see now, I'll focus on XState. And at this point, credit where credit's due. It was created by David Khurshid. He's having lots of talks about this topic as well, and he's a great speaker. So if you have the chance, go see him. So how do we get our visual model of a state machine into code? With XState, you get a constructor called machine. You pass in a list of its states, idle, calling, active. You say, hey, on input call, you transition to call it, and you have an initial state in the beginning. And when you're using one of those fancy modern UI solutions, it also provides you with functionalities or functions to implement the state machines. So here you can see there's that magic use machine that I pass my definition into, and it gives me back 2 things, current, my current state, and send, which sends inputs to my state machine. And when rendering the UI, I can check, hey, is the current state active? If so, render a button, add person, and when it's clicked, it sends a transition, and all the rest is done by my state machine. I could even send the event to the state machine in the wrong state, and it wouldn't do anything because it knows that it's in the wrong state to run the routine. The most amazing thing is that XState has an inspect plugin, basically, that lets you visualize your code in real time. So what's running here on the left is a Vue.js app, which is a timer, and on the right-hand side, you can see how your state changes when you play, when you pause, or you can even play with your app inside the inspector and reset the time, stop it from there, and it's quite easy to see what's happening. You can quickly debug why you have side effects, and you see what went wrong because your mental model is suddenly not only mental anymore, but you have it visualized. So in summary, we can say that with state machines, you are free from unexpected states and transitions. You have all your logic in one place. You have a clear separation between your user interface and your logic. And again, the best thing, you have a visualization of all that. And if that's your kind of thing, it's all written in TypeScript. You get all type-safe code if you want. But wait, there is more. There's another mathematical concept that's already also 20 years old, and it's called model-based testing, which is a testing approach where test cases are automatically generated from models. And what is a model? A model is an abstraction of a real-world function. But where do I get a model of, my real-world function? I mean, look at that. My state machine, my state chart is exactly this. It is an abstraction of my working app, and it shows how I expect my application to work. So are you telling me, Robert, that I can use state machines to automatically generate my tests? Yes, that's what I'm saying. And the amazing thing is that if you change your model, your state machine, your tests are automatically updated as well. And here you can see a test run of that. That's a TikTok implementation, tic-tac-toe, sorry, not TikTok, tic-tac-toe implementation of a state machine. And XState gives you a test package that generates with the shortest path algorithm all possible ways through your application, and it just runs those tests. And you can see it just clicks through everything that can happen. And I'm going to spare you the rest of this because XState for tic-tac-toe generates 5,478 tests. And I mean, that's tic-tac-toe, all right. But if you have a number like this for tests, that might be even lower for real application, you are almost certainly going to forget one side effect, one little feature there, one function on the other side. And XState helps you to discover the things that you might have forgotten. So, alongside everything else I've just said before, you also get tests for almost free. And that means you spend less time hunting down bugs and get more time for drinking beer in your favorite bar. So I hope that I could show you how excited I am about state machines, and I hope that you take a bit of that excitement back home tonight maybe, download XState and play with your state machine. Thanks.
Thank you. This was very fast.
Yeah, it was.
Okay, leave no more time for questions, and I have such a good question for you.
Oh, God.
This question comes from Tino. I'm not sure if you can answer it. The question is your hair real?
It is, it is.
Okay, that's all we have. All right.
All right.
Okay, no, there are more questions. And also, again, you can raise your hand, ask a question directly. Nope. Okay. So this question comes from Anonymous. Is there a lower boundary of complexity where you would use a state machine? What about an accordion?
That's a really hard question. As always in software engineering, it depends. I think an accordion is something that I wouldn't go with the state machines. There are different libraries. If you pull in XState to your project, there are quite a few kilobytes that you pull in. It might not be worth it, but there are other libraries with a lower footprint. But what we try is, if we aren't already using a library for state machines, we try to apply the mindset, the concept. So with React, we try to use reducer rather than use state, because it helps us thinking in states of the application and not only data. But it's always worth a discussion in your team, I think.
Yes.
But one example I can maybe add, we had, on our own website a couple of weeks back, we implemented a small wizard where you could click through and answer a question, and in the end, you'd get a contact form, basically. And we started without the state machine and quickly realized, hey, the code gets out of hand, so we started using a small package for that.
So iterating.
Yeah, absolutely.
All right. Cool. Next question comes from Daniel. Why should I use a JS library for what can be achieved by simply drawing a UML state diagram on a whiteboard?
Well, it doesn't give you code in JavaScript, right? And state machines, what we've seen here is only the visualization of your code, so it's the other way around. You implement the model, you implement the logic, and XState gives you the visualization of what you want. And then UML goes the other way, but doesn't give you ready-to-go front-end code.
Makes sense. All right. Any questions from the audience here? Yeah, people are too shy. All right. Okay, so here's a question. Did you replace state containers like Redux in your toolchain with state machines, or do you rather combine them?
yes, we replaced them. That was actually the reason why we got into it. We loved the thought of having a clear separation of concerns and having our React components and all logic, all state externally with Redux until we implemented a new application, and it grew and grew and grew. And there was a point where even we didn't know what was going on inside the application anymore. And then we had to onboard new team members and try to explain them what they were going to work on. But we didn't really understand it ourselves anymore. And we somehow finished the project. It's still running. It's still working all right, I guess. But when the next project came, we said, hey, that can't be the way anymore. We need to find something else. And it was a greenfield project. And that's when we stumbled upon state machines again and decided to try it out. And that was, I think, 3-4 years ago. And we've been using it on almost every project since, and no Redux anymore.
Okay, cool. So here's another question from Tino. Is your beard real too? No, wait, that's not the question. The question is, can you recommend a good way to start? Are there easier ways than XState?
Phew. I mean, the problem with XState, I'd start with XState. But it comes with many concepts. It quickly introduces you to model-based testing. It quickly introduces you to the actor model, which I haven't even touched today. And there's a lot of complexity in it. But if you go through the tutorials, it takes you there step by step. It starts with an easy state machine. Then there are like async services where you fetch data from somewhere. So easy way. I mean, there's robot also, which might be a bit simpler to get into it. But yeah. Not really. I'd start with XState anyways. Sorry, quite biased here.
You heard it here first. All right. Oh, we have so much time, by the way. And get your questions in. We have so much time. It's all fine. So this question is coming from Luca. In JS, which I think means JavaScript, states are immutable to fulfill the mathematical definition you said, which means deep cloning objects in arrays, right? And there's more questions. How to overcome, I guess, bottlenecks in performance, or how would you overcome bottlenecks in performance? Because you have to deep clone arrays. Yeah. I didn't understand the question. Okay.
That's right. So the answer is yes. There is also a problem with performance there. We used immer, but we've already been using that with Redux, and XState also has kind of an extension for immer to make sure that it's properly implemented. And I remember when we've been using it with Redux, we ran into the performance issues, but there were new releases that helped us a lot. And in all honesty, we had other bottlenecks, so it wasn't our main focus. But in that case, let's say we trust the library, and I'm sorry, I can't give you a better answer, but maybe you can come to me after the talk and we can go deeper into this, because I have some people in here that know it a bit better than I do.
What? You didn't invent state machines? All right.
Do you think I'm that old?
Your hair looks kind of suspicious. All right, so are there any more questions? I think this is the last question on Slido. If not, we can take like a little bit of a longer break. Thank you so much.
No worries.
Great talk. Give him a hand.